Hello, hello. So today we are going to talk about null and alternative hypotheses, or the null and the alternative hypothesis. So this is a huge kind of fundamental lesson for every lesson until we start reviewing for the AP exam. Writing the null and alternative hypothesis is the start of all these different tests that we're going to do. So it's section 9.1 in your textbook. Please go there to follow along and see additional examples in your book problems. So what are the null and alternative hypotheses, and why do we talk about them? In statistics, a huge part of statistical inference is making decisions on whether we can call something fact or fiction, whether we can accept a claim or say a claim is true, or whether we say a claim is false. So significance tests are the kind of systematic process to get us to our final answer. And how we start a significance test is by writing our hypotheses or writing our predictions. So I really like this little comic down here. It says statistics to test hypotheses in your patients. These tests are going to be long. They're going to be really long. There's going to be a lot of writing, and it will test our patience at some point. But the cool thing is that these tests help us prove claims, and you're going to see a lot of very practical and worldly examples of claims that you see every day. So significance tests, we look for evidence against a claim rather than in favor of. So we're always looking to reject or fail to reject something because we're looking for evidence against a claim. And in order to disprove a claim, we have to make a claim or create hypotheses. We have two types of hypotheses, the null hypothesis, or the HO, and then the alternative hypothesis, or the HA. So what's the difference between these two hypotheses? If we start out talking about the null hypothesis, or HO, it says the parameter, or the population value, is the same as or equal to the claimed value. You can also think of it like you're innocent until you're proven guilty. So we always start off saying that the population value, or the true value, is the same as what they're claiming it to be. So whatever the claim is, we set the parameter. Well, for means, my parameter is mu. So we would say that the null hypothesis is mu equals the claim, and the claim is going to be the average given to us in the problem. For proportions, we use p for the parameter. So the null hypothesis for proportions would be p equals the claim, or whatever proportion or percent is given to us in the problem. So that's the null hypothesis, or the nothing's different, there's no change, it's equal to hypothesis. But we also have the alternative hypothesis, or kind of what we think is true. So the alternative is like the, what do I think is happening? So it says that there's a difference between the parameter and the claim. So we think that it's either less than, greater than, or not equal to. The alternative hypothesis is saying the difference we see between the statistic and the parameter is more than random chance. Essentially, it's saying that the claim is false. It's saying this claim, this null hypothesis, is not true. That's the alternative. Three types of alternative hypotheses, or three options. So the first option, and make sure you get all these notes down. Everything on these slides is super important. So the first alternative hypothesis is that we think the mean is greater than the claimed mean, or the proportion is greater than the claim. If I think about things being greater than, I'm shading this area up here. So eventually, we're going to end up finding z-scores and finding critical values, and then finding the area above them. So alternative hypothesis 1, we think it's greater than, so we're shading above. Alternative hypothesis 2, we think that the true mean is less than the given one, or the true proportion is less than the given proportion. So we shade below, or it's a negative one-tailed test. The last option is if I just think it's different than. So if I think the true mean is different than the one they give me, or the proportion is different than the one they gave me, it's going to be called a two-tailed test, which is where I shade below and above the z-score, or the critical value that I find. So there's 3 types of alternative hypotheses. Your problem will prompt you onto which one to use. Which brings us to our first key point. A significance test is two-tailed, where we shade both sides, if we want to know the probability of it not being equal to the claim. So if the problem does not give a prompt of more than, greater than, or less than, fewer than, it's most likely a two-sided test. So the problems are going to be very specific, as you're going to see, as to whether or not you use more than, less than, or not equal to. So here's an example for us to kind of put in our example bank. It says define the population and parameter of interest and write the appropriate null and alternative hypotheses for the test that is described. So it says the mean weight of loaves of bread produced at the bakery where you work is supposed to be 1 pound. You are the supervisor of quality control at the bakery, and you are concerned that new personnel are producing loaves that have a mean weight more than 1 pound. So if this is the scenario, and I have to start out with the population, I would say the population, or the who. Well, I took a sample, and I'm checking the loaves of bread, so the population would be all loaves produced. The parameter, or what I'm measuring, is their average weight. So we want to estimate the true average weight, which is going to be my mu. So we're trying to estimate mu. So I did population, parameter. Well, now I need to write null and alternative hypotheses. Well, the null hypothesis, or HO, is that the true mean equals 1 pound. So I'm comparing it against 1 pound. The null hypothesis is always equals, so it's that the true mean equals 1 pound. Oops, did not mean to erase that. The alternative, or what I think is going on, is that the mean weight is more than 1 pound. So I think mu is greater than 1. And that's how I set up my problem. I always write the population, parameter, null, and alternative. This is going to be the state step in our 4-step state plan do conclude process, and we'll talk more about that in a minute. So this is example 1. This is all I need. Example 1, part B, define the population and parameter of interest and write the appropriate null and alternative hypotheses. So it says, according to the Humane Society, 33%, so that's a number, I'm going to kind of underline that, 33% of households in the United States own at least 1 cat. You are interested in determining whether the proportion of households of the students at your school that own at least 1 cat is different from the national proportion. So if I start off with my population, who am I testing a claim of? Am I testing a claim of all households in the United States or households of students at your school? The population is actually households of students at your school. Since I'm comparing the national average with students at your school, and this is who I'm taking a sample of, that's my population. The parameter, or what I'm measuring, is we want to estimate the true proportion of students who own at least one cat. So this is my population and parameter. We've done these before. The next part is my null and alternative. Well, if I think about the null hypothesis, it's always my equals hypothesis. But if I think about this problem, is this problem talking about means or proportions? It's talking about proportions, so the null is that the proportion equals the national average of 0.33. The alternative is that the national average is different from or not equal to 0.33. So this is an example of a two-sided test. When I do the significance test, which we're going to do not in this video, and a couple down the road, when I do the significance test, I'm going to have a little normal curve where it's shaded on both sides. But for now, I'm just writing the null and alternative and stopping there. So the second example is a multiple choice example. Multiple choice is very important. It's a huge part of the AP exam, a huge part of IAs and other tests in our class. So here's some example. It says an opinion poll asks a simple random sample, see that word again, it's super important that it's random, of 100 college seniors how they view their job prospects. In all, 53 say good. Does the poll give convincing evidence to conclude that more than half of all seniors think their job prospects are good? If P is the proportion of all college seniors who say their job prospects are good, what are the hypotheses for a test to answer this question? Well, if I just do process of elimination and think about the null hypothesis. The null hypothesis is that the proportion, it's proportion because it's talking about 53 out of 100, or the proportion given to us right there. So the null hypothesis is that P equals 0.5. How I got the 0.5 is the more than half of all seniors. So the null hypothesis is that P equals half. And if I think about kind of process of elimination, if I look at answer A, the null hypothesis is P equals a half, so I'm going to keep that. B says the null hypothesis is P is greater than a half. Well, the null hypothesis is always equals, so I can get rid of B. And if I look down to E, I can also get rid of E. So B and E are out. I'm down to 3 options. The alternative hypothesis is going to be the proportion, or P, is more than a half. So that more than a half right there tells me the alternative is that P is greater than 0.5. And if I look, that's going to be answer choice A. So these are the 4 steps, like I said, of conducting a confidence interval or a significance test. The state, plan, do, conclude. State is the same population and parameter, but now I'm also adding the null and alternative hypotheses to the state step. Plan is actually going to be random, normal, and independent again. And then the do and conclude steps are very similar, just with the formula changing in the do step. So we're going to go through these steps in every video that we talk about, or every video where we talk about significance tests, but today we're focusing on the state step. Which brings us to key point 2. We write the hypotheses for every significance test. The null and alternative are part of the state. So when we think about the 4-part process, null and alternative, population and parameter are all part of the state. So that's a wrap. In order to conduct a significance test, we need to state the null and alternative hypotheses, the null, HO, alternative, HA. The null hypothesis is always equal every single time, and the alternative is always against the claim, and it's either greater than, less than, or not equal to. So this is section 9.1 in your textbook. Look there for extra examples and for your practice problems. I'll see you next time.